So in this video, we will learn what is harmonic function. So what is harmonic function? A function satisfying Laplace's equation in its domain is called harmonic function. Okay. So how we represent the Laplace's equation? Laplace's equation is represented as del square t by del x square plus del square t by del y square equal to 0. So this is known as Laplace's equation. Okay, so what is harmonic function? A function satisfying Laplace's equation in its domain is called harmonic function. So it is harmonic function is also a very important part of complex theory. Okay, complex analysis. So for complex analysis you can also consider at least 5 to 10 marks questions from harmonic function. In my previous video for complex analysis I have already given you notes for analytical function and also giving you the question answers for analytical function. So now I am giving you the giving you the note for harmonic function and also give some example of harmonic function. Also give some problems of harmonic function which often come in university examination. Okay, so now since fz, so if fz is analytic, okay, so I hope you understand what is analytic function, because in the previous video I have given you the notes for analytic function as well as question answer. So if fz is analytic, so it's then in obviously it will satisfy this Cauchy-Riemann equation. Okay, it will obviously satisfy the Cauchy-Riemann equation, and that is del u del x equal to del v del y, and del y del u del y equal to minus del v del x. Now differentiating partially with respect to x from equation number 1. Okay, what we will get? We will get del square u del x square, del square u del x square equal to del square v del square v del x del y, equation number 3. Okay, the equation number 1 was del u del x equal to del v del y. Okay, if we differentiate it with respect to x, we will get del square u del x square equal to del square v del x del y. Okay, then we will give this equation name as equation 3. Okay, now differentiating equation number 2 partially, what we get with respect to y, what we will get? We will get del square u equal to del y square equal to minus del square v del y del x. That is, then we will give the name of the equation to equation number 4. Okay, equation number 4. Now equation number 3, now adding equation number 3 and equation number 4, what we will get? We will get that del square u by del x square plus del square y by del y square equal to 0. We give the equation name is equation number 5. Okay, now similarly for transform equation 5, we get del square v del x square equal to del square v del y square equal to 0, and give the equation name is equation number 6. Okay, now since the function u and v both satisfy the Laplace's equation, therefore u and v are harmonic functions. Okay, so this is how we can say that the function is harmonic. So if you are asked to prove that whether, or asked to check whether a function is harmonic or not, in this way you can check this. Okay, now what is conjugate harmonic function? If a function fx is analytic in any domain, in any domain, if a function fz is analytic in any domain, then u and v both are harmonic in that domain and are called conjugate harmonic functions, or simply conjugate functions. So if u is given, then for v we can solve the derivative dv equal to del v del x dx plus del u del y dy. Okay, if v is given, then for u we can solve the derivative as du equal to del u del x dx plus del u del y dy. Okay, now just go through some question answers. Okay, the question is, prove that the following function is harmonic. Okay, following function is harmonic, and prove that the following function is harmonic and obtain the conjugate function. Okay, this is the question. This question often come in university examination. That is why I am giving you the example. Prove that the following function is harmonic and obtain the conjugate function. Okay, so the function is u xy equal to 2x into 1 minus y. Now solution, left hand side, del square u del x square plus from Laplace's equation we know that del square u x plus del square u del x square plus del square u del y square equal to 0. So now we just differentiate it right now. Differentiating, what we will get, del u del x equal to 2. We have to prove that del square u del x square plus del square y del y square equal to 0. If we can prove that for this function, then we can say yes, the function is harmonic because it is satisfying the Laplace's equation. Okay, so now let's start the differentiating. So first we will differentiate u with respect to x, and we will get 2 into 1 minus 1, and again differentiating, what we will get 0 because y is constant here. Now differentiate u with respect to y, what we will get 2x into minus 1, that is minus 2x. Okay, and then again differentiating, we will get 0, correct? Hence del square u del x square plus del square u del y square equal to 0. Therefore u is harmonic function. Okay, now for conjugate, now for conjugate function v of u, okay, what we have to do, we have to do that dv equal to, we have to, I have already given you in the previous page, you have seen that for how can we determine the conjugate function. So we are doing that thing. So dv equal to will be the del v del x dx plus del v del y dy, and dv equal to del u del y dx plus del u del x dy. Okay, now by CR equation, 2x dx plus 1 minus y dy, it will be 2x dx because this will be replaced by 2x dx, and del u minus del u del y will be replaced by 2x. Okay, and del u del x will be replaced by 2 into 1 minus y. Okay, through by the Laplace's equation. Okay, we know that by the CR equation we know that. Okay, now taking integration both sides, what we will get, dv equal to 2x dx plus 2 dy minus 2 integrating, we will get dv equal to integration of 2x dx plus 2 integration dy minus 2 y dy. So that will be x square minus y square plus 2y plus c. So that will, the result will be x square minus y square plus 2y plus c. Now we have to check, now we'll check the uxy part. Okay, so what will be the uxy part? This is the second part. Okay, that question I have not actually, this is not included in the question part, so you can consider this another part of the question. Okay, so uxy equal to x cube minus 3x square y plus 3xy square minus 3y square plus 1. Okay, so what we will get for del u del x, we will get 3x square minus 3y square plus 6x, and then del square u del x square equal to 6x plus 6, and then for del u del y part, what we will get, minus 6y minus 6 minus 6xy minus 6y, and del square u del y square equal to minus 6x and minus 6. Okay, now if we just add these two functions, that is del square u and del x square plus del square u plus del y square, what we will get, 6x plus 6 minus 6x minus 6, that will give us 0. So we can say this function is also harmonic. So this is how we can check the harmonic function. Okay, now again we will check, we will have to actually find out the conjugate part. So that is why we are finding now the conjugate part. Okay, so how can we find the conjugate part? Conjugate part can be find like this: dv equal to del v del x dx plus del u del y dy, and dv then we can write du equal to del v del x dx plus del u del v del y. Okay, that can be written like this, that minus del u del y dx plus dv del x dy. Okay, so that is 6xy plus 6y dx plus 3x square minus 3y square plus 6y dy, and that we can write like that, 6xy dx plus 6y dx plus 3x square dy minus 3y square dy plus 6x dy. Okay, now integrating both sides, what we will get, integrating both sides, we will get, if we integrate dv, then we will get v, and then if we integrate dxy, 6 dxy, and then 6d plus 3d x square y minus 3 y square dy, what we will get, v equal to 6xy plus 3x square minus 3 y cube by 3 plus c, that will give us v equal to 6xy plus 3x square minus y cube plus c. Okay, so this is all about harmonic function. If you just go through the definition and the examples I have given, I think you can secure the 5 or 10 marks that will come in your university examination. Okay, So thank you for watching. Please subscribe my channel to get the updates.